Yo, what's up, dude? Today we're gonna be talking about the distance formula. So this is usually like, one of your first equations that you learn when you take like a geometry class, either in your freshman or sophomore year of high school. And this is just, a way to get familiar with geometry. Distance formula, it seems like a very, very random formula when you first learn it. It's on your formula sheet, obviously. But when you see, you have x2 minus x1 squared plus y2 minus y1 squared is equal to the distance, it looks pretty weird. However, I'm here to show you why it's not weird. And here's the thing, y'all. I remember I made a video on this called Pythagoras. Pythagoras, yes. This equation is just Pythagoras in disguise. That's literally it. Except when you look on a grid, it looks very, very different, doesn't it? So let's say like you had your XY coordinate grid. And for the first for my first example, we're gonna take the coordinates of 1, 2, and 5, 5. So let's just imagine that 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I don't know where 5 is. I'm gonna say this is 1, 2, 3. I think this is 5, 5, and then 1, 2 is gonna be around here. So you could see already that from 1, 2 to 5, 5, it's gonna be this line right here. However, you can also see that you have this many steps going that way and this many steps going that way. So essentially you have 1 to 2 to 5, 5. So the distance from 1 to 5 is 4 in the x direction, and for the y direction is 3. So already, if you know your right triangle theorems, you can already tell that the distance is going to be 5. Because of the Pythagoras theorem, you have 4 squared plus 3 squared is equal to 25. And then square root that, they get 5, which is the distance. However, I'm going to prove it to you why distance formula actually matters and why it works. And why it's better than, kind of relying on a triangle. So look, we already figured out that the distance was 5, right? But now we have to prove it with the formula. So first off, this is write our formula. And then this is write our x2, y2, and y1, x1. So our x2 is going to be 5 minus x1, which is 1, squared, plus y2 minus y1 squared is equal to the distance. So now we have root 5 minus 1, 4 squared, plus 5 minus 2, which is 3 squared, which is equal to the distance. 4 squared is 16, plus 3 squared, which is 9, this is 25. And then the distance is just equal to 5. So the math works. The math works. But now let's get into a sticky situation where you have negative numbers. So now we're going to find the distance of negative 3, 4 through to negative 8. And now, of course, you can always make a right triangle for this. However, let's say you're struggling on something, hopefully not. You can always use the formula to bail you out. So negative 3, 4, 1, 2, 3 is going to be in the second quadrant. Because it's going to be 1, 2, 3 to your left, and then 1, 2, 3, 4 to your up. Oh, to your positive y direction. I'm so sorry. Don't tell your math teacher I said that. And then it's going to go through 2, which is going to be in your fourth quadrant, because it goes 1, 2, 3, 4. And 2 negative 8 is going to be somewhere around here. I'm not really trying to do all that. You can do, your little triangle and stuff. I wouldn't recommend it though, because I don't want to count that much. And also it's easier. So it's easier to just set up your stuff. So let's do it, shall we? So obviously we have our formula. X2 minus x1. X2 in this situation is 2. Then we're going to minus a negative 3 squared plus y2, which is negative 8, minus 4 squared equal to distance. And essentially, this is Pythagoras theorem all over again. You get root 2 minus negative 3. And remember, for your negatives, this is going to be a positive 5 squared plus negative 8 minus 4, which is negative 12 squared, equal to your distance. And essentially, this is another perfect right triangle. This is going to be 25 plus 144, which is equal to root 169. And this actually turns out to be 13, which is equal to our distance. Pretty simple, right? And let's go to our final example. And I'm going to change up the color for a little bit because, I want to change up the color. So now we have negative 2, 3 through 4, 5. Now, not every number you're going to get on your test is going to be a perfect square root. You're not always going to get 5 or 13 or 12 or something like that. And here's why. So I'm going to show you again on the corner graph. It's terrible, but work with it. So we have negative 2, 3. 1, 2, 1, 2, 3. Then we have 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5 is right here. So this is going to be about this. It's about that. So now we're going to do our little formula again. x2, y2, x1, y1. x2 in this case is 4 minus x1, which is negative 2, squared, plus y2, which is 5 minus 3 squared, equal to your distance. From here, we take, negative. We add it to make it a positive because negative minus negative is a positive. So this is 6 squared. 4 minus negative 2 is 6 squared, plus 5 minus 3, which is 2 squared, equal to distance. So now from here, the reason why I say that you're not always going to get a perfect answer is because sometimes your answer is going to simplify to be this. Root 40 doesn't really work out to be a square root. So again, you're going to have to work on your radical skills. Let me show you how to work on that. We have radical 40, which just means that we can't simplify this to a completely solid number. However, we can simplify to its radical form. So we just have to find the square value that matches up most, or we find the square value that we can divide the number most by. And here's what I mean. These numbers are way too big and they don't fit. 9 doesn't fit either because you can't get a number that's solid that multiplies up to 40. 1, you can't do 40 times 1 because that's just itself. So 4 is just going to be your perfect. So here's what I mean. You simplify 40 into your 10 and then into your 4. And then you can't square root 10, so you just leave it as a square root. However, you can break down 4 to be 2. So now you get 2 square root 10 as your radical. And therefore, 2 square root 10 is equal to your distance for this specific example. So this is just breaking down distance, distance formula. Even though this formula seems very, very simple, it definitely gets more complex the later you use it. Even in calculus, he still uses formula a lot. So thank you for watching. Hopefully you enjoyed. Hopefully you took something out of it. And goodbye.